In this example, I'm going to call it SAD chest. I mean, technically, I guess it's abdomen, but it's going to be an APPA spine treatment. So SAD chest 1 is going to be APPA calculated to isocenter with an SAD technique. So we're going to be using tissue max ratio and inverse square factor rather than percent depth dose and a nominal SSD of 100. I have two fields here. Field 1 is from the AP, field 2 is from the PA. I don't have any MLCs, but I do have asymmetric jaws. Basically what I've given myself is a 2 centimeter margin around the vertebral bodies, and then from sup and inf I've just tried to include a number of vertebral bodies. I'm calculated at a water equivalent phantom as well, so no heterogeneity corrections in this example, which is fine. If we did have heterogeneity corrections, the only thing that you would have to do is use the water equivalent depth for your monitor unit calculation. This example is going to be calc to isocenter. I have 250 centigrade times 10 fractions. 250 centigrade times 15 fractions is 3750, which would be maybe a classic palliative dose. My reference point is isocenter, and I'm prescribed at 100%. My monitor units are at 157 and 158. I want to calculate my monitor units by hand. First thing I need to do is find out the equivalent square. Is going to be length times width times 2, 4 times the area divided by the perimeter, length plus width. All right. My X jaw is 8, my Y jaw is 14.5. 8 times 2 times 14.5 divided by 22.5 gives me roughly 10 for equivalent square. Normally we would interpolate again by linear interpolation. However, for the sake of time, I'm just going to round to 10 centimeters. So I pulled out my data tables while my machine's calibrated at a 10 centimeter equivalent square field size. So my collimator scatter factor and my phantom scatter factor are both 1.0. If I look at my depth, for field 1, I am at 89.9 for an SSD, and my depth is 15.1. My dose is 125. Again, I have a 50% beam weighting, and I'm delivering 250 centigrade, so 250 divided by 2 is 125. Collimator scatter factor is 1, phantom scatter factor is 1, tissue max ratio, if I go to a 10 centimeter field size and I go down to a 15 centimeter depth, I'm at 0.635. My isodose line is 1 because I'm prescribed to the 100% isodose line. And my inverse square factor is source to calibration distance, 101.5, divided by source to calculation point distance, which is at the isocenter, is 100 squared. Again, that's a standard inverse square factor for calculating the isocenter of 1.03. And I don't have any off-axis factors since I'm calculated to ISO. .125 divided by 0.635 and times 1.03. That doesn't look right. So what did we do wrong? Maybe I looked up the wrong depth. So if we go to print, report, I looked up the calc point depth of 15 centimeters. So my phantom is 20 centimeters and to post thickness, so my spine ISO depth is 10 centimeters deep. So that's where I made my mistake. So if I pull my data tables back in, I go to a 10 centimeter field size and 10 centimeters deep, 0.774 is my tissue max ratio. So if I take 125 divided by 0.774 divided by 1.03, I get 156.8, or 157 if we round up, which is what my MU from the anterior are. So that's better. So you can see that we made a gross mistake before. I mean, it was 190 monitor units divided by 157 puts me at a 20% error. So the tissue max ratio was off because I looked up the wrong depth. So APPA, clinically the dose distribution again is a classic parallel opposed dose display where we have percent depth dose characteristics from the anterior, percent depth dose characteristics from the posterior, and then we get this hourglass shape in the middle. The thicker our patient goes, the more pronounced this hourglass shape is, and the higher our maximum dose is, since we have to normalize to a deeper depth. The next video, SAD Chest 2, is going to calculate monitor units to a calculation point not at isocenter.